Standard 5. This time we will solve equations. Question 1. Let's expand all the terms and we shall see if anything simplifies. Expanding the left hand side, expanding the right hand side. Left hand side, we have 2x squared. If we are to isolate all the terms, we will get nothing, 0x squared minus 4x plus 8 is equal to 0. So therefore, 4x is equal to 8 or x is equal to 2. Question 2. 3x minus 1 times x plus 2 times 4x minus 3 is equal to 0. The product of the factors is equal to 0 if one of the factors is equal to 0. For this to be true, 3x minus 1 is equal to 0, or x plus 2 is equal to 0, or 4x minus 3 is equal to 0. So x is a third, or x is negative 2, or x is 3/4. Done. Question 3. 1 by 4 x squared minus 3x minus 2 squared is equal to 0. The simplest foolproof way is to use the difference of squares. A quarter of x squared, that is actually 1 over 2x squared. A squared minus b squared, that's a minus b, times a plus b. So negative 5 by 2x plus 2, 7 by 2x minus 2. This is true if either this is true or the other one is true. Negative 5 by 2x is equal to negative 2. X is 4 by 5. Alternatively, 7 by 2x is equal to 2, or x is 4 by 7. Therefore, x is equal to 4 by 5, or x is equal to 4 by 7. If you choose not to factorize using the difference of squares, sure, you can expand brackets and then you can use a quadratic formula, but that will make your life miserable, especially without a calculator. Question 4. We want to solve x minus 2 divided by 4 plus 2x minus 3 divided by 3 is equal to x minus 18 divided by 6. We are going to multiply both sides of the equation by a factor that would completely get rid of the denominators. To do that, we need to find the lowest common multiple of 4, 3, and 6, which is 12. If we multiply 12 to both sides of the equation, we will obtain this. 3x minus 6, 8x minus 12, 2x minus 36. Swap it over. 9x is equal to negative 36 plus 18. 9x is equal to negative 18. X is therefore negative 2. Done. Question 5. Now it's getting a bit more interesting. So first, we need to simplify the algebraic fractions on the left. To do this, we will use a very similar method that we just used in the previous standard. Step 1, we're going to factorize all of the numerators and all of the denominators. Step 2, we will then identify the lowest common multiple of all of the terms. Our common denominator is going to be 2x plus 1 times x minus 3 times x plus 3. Therefore, we need to multiply the first term with x plus 3 and multiply the second term with 2x plus 1. 4x squared plus 7x minus 15 minus 4x squared minus 2x divided by this massive abomination of a denominator. That cancels out. We're down to 5x minus 15. Luckily, we can simplify this. By factoring the 5 out, you can now simplify the top and the bottom. The non-permissible values are negative half, 3, and negative 3. And because x cannot be equal to 3, we can simplify the fraction without losing any solutions. For this to be true, therefore, 2x plus 1 times x plus 3 has to be equal to 3. 7x plus 3 is equal to 3. So x is either 0 or negative 7 by 2. This is a long question, and this is the level of algebraic fluency that I'm expecting from AAHL students if you are to get a 7. Question 6. 49 to the power of x times x minus 10 is equal to 2 to the 3 divided by 7 to the 48 plus 7 to the 49. This is scary. Let's leave the left-hand side as is. On the right-hand side, 2 cubed, that is equal to 8. If we factorize the 7 to the 48, we have 1 plus 7. So those cancel out. Luckily, 49 to the power of x times x minus 10 is equal to 7 to the power of negative 48. 49, that is 7 squared. The two are equal if and only if this is true. Divide everything by 2. Swap it over. Factorize. And your two values are 4 and 6. Moving on to simultaneous equations. Simultaneous equations also show up all the time on exams. The IB loves this. They will give you a function with two unknowns. They give you two pieces of information. From there, you will get the two equations and solve the simultaneous equations to get the values of the two unknowns. So, if you cannot solve the basic linear system of equations or linear simultaneous equations with ease, you are at a severe disadvantage. Question 1. 4x plus y is equal to 2 and 8x plus 3y is equal to 5. We can pick one of the two variables. Let's go with x. We want to multiply a constant to the first equation and a constant to the second equation so that the coefficient of x is the same. To do this, let's say that I'm going to multiply the first equation by 2 and the second equation by 1. In other words, keeping it as is. Subtracting the first equation from the second equation, we have y is equal to 1. Plug it back up into the first equation. Therefore, the solution to your system is 1 by 4, 1. Question 2. You now have another system of equation, but this one looks a bit more intimidating. If you're good with your algebra, you don't need to make any substitution. If, however, this intimidates you, please feel free to use a dummy variable once again. So let's say a is equal to x divided by x minus 1, b is y divided by y plus 2. The equations become a plus 2b is equal to 3, 2a minus b is equal to negative 4. Multiply the second equation by 2, and now we can add the two equations. Keep one of the two equations for a beginning. A is negative 1, and therefore b is equal to 2. We're not done yet. Our system is in terms of x and y. Therefore, x divided by x minus 1 is equal to negative 1, and y divided by y plus 2 is equal to 2. X is negative x plus 1, y is 2y plus 4. Y is equal to negative 4, x is equal to a half. So x comma y is a half comma negative 4. Question 3. 2x squared minus 3y squared is equal to 15. Y is equal to x minus 2. When solving non-linear systems of equations, substitution is usually the way to go. Since y is already expressed in terms of x, we can just plug it straight into this. Expanding the brackets. Be careful with the pesky negatives. Multiply everything by negative 1 because I do not want to play with this. And we have 3 and 9. So x is equal to 3 or x is equal to 9. Y is x minus 2. So y is equal to 1 or y is equal to 7. Therefore, xy is either equal to 3, 1 or 9, 7. One more standard to go. Standard 7. Inequalities. Question 1. 3 times 4u minus 1 minus 5 times u minus 3 is less than 9. Expanding the first bracket. Expand the second bracket. Collect like terms. Since we are dividing both sides by a positive number, the sign does not change. That's it. Question 2. You are given that a and b are positive and 0 is less than a less than b. Part A. The inequality sign does not change if we multiply everything by a positive constant. If we add the same quantity to both sides of the inequality sign does not change. And that's question 2. The second part, if 0 is less than a less than b, then 0 is less than a cube is less than b cube, correct? B cube is less than b cube plus 1. If I want to be even more precise, I can say 1 is less than b cube plus 1. Therefore, a cube divided by b cube plus 1 has to be less than 1. Another way to look at this, if 0 is less than a cube less than b cube, a cube divided by b cube has to be less than 1. However, b cube plus 1 is even greater than b cube. So now we have a larger denominator. Therefore, this guy must be less than that guy, and therefore less than 1. Question 3. We want to solve the inequality. Moving everything to one side, factorize, and solve. We want to find the interval of a so that the quadratic is less than 0. The two roots are 3 and 5. This doesn't have to be to scale. We know that the coefficient of a squared is positive. So we're going to have a parabola opening up. Therefore, it is less than 0 if it is between 3 and 5. Done. And the last question. We want to find the set of values of x that satisfy both inequalities. So let's start with the first one. We have a difference of squares. Following the same method as above, the two roots are negative 5 by 2 and 5 by 2. The parabola is going to look something like this. The inequality is true if x is between negative 5 by 2 and 5 by 2. For the second inequality, we will first isolate. We will first move all the terms to one side. Factorize this guy. Follow the same method once again. The two roots are negative 1 by 3 and 3. The coefficient of x squared is positive, so it is opening up. So it is greater or equal to 0 if it is on either side. So x is greater or equal to 3, or x is less than or equal to negative a third. Now let's represent these guys on a number line. For the first inequality, we know that it is true between negative 5 by 2 and 5 by 2 exclusively. For the second inequality, we know that it holds true for x greater than 3 or x less than negative 1 by 3. So for the first one, this is the solution set. For the second one, this is the solution set. And now we want to find the intersection of the two. What values of x would satisfy both inequalities? Negative 5 by 2, negative a third, 0, 5 by 2, 3. Not this interval. If it is between negative 5 by 2 and negative 1 by 3, this is good. Between negative 1 by 3 and 0, no. Between 0 and 5 by 2, no. Between 5 by 2 and 3, no. And after 3, no. Therefore, the only interval that we can accept is between -5/2 strictly less than x less than or equal to -1/3. And that is the end of the test. I hope that you found this a useful revision going into DP1. If you find yourself struggling with some of these questions, please reach out for help. I have also posted a booklet on foundations of algebra that you can use to brush up your algebraic skills. But of course, you can use any other sources that work better for you. I have also posted 2 more unit tests on the website on the same topic. So hopefully this will get you ready and prepared for DP1. Looking forward to embark on this journey together with you. Enjoy and have fun.